Next, I'll revisit the heating curve for water. And this question says, calculate the heat required to heat 7 grams of ice from negative 15 to 115 degrees C. But as an example, I'm going to revisit the example we looked at earlier where we're heating 18 grams of ice to above 100 degrees C to 125 degrees C. Okay, so I'll let you work the 7 grams from negative 15 to 115 as a separate exercise. So notice that we have these 5 regions that we're covering. We're covering from, and again, we're going to heat 18 grams of ice from negative 25 degrees C to 125 degrees C in this example. So we have Q1, Q2, Q3, Q4, and Q5. Okay, so in our example, we're heating 18 grams of ice from negative 25 degrees C to 125 degrees C. I'm going to let you work this problem separately. Okay, so first we have Q1. Q1 is going to be governing the warming of the ice. So we have 18 grams of ice, and this region is governed by the M C sub S delta T equation, where C sub S is the C sub S for ice. Delta T is T final minus T initial. So 1 mole of ice is 18 grams of ice, and here we have 18 grams of ice times the C sub S for ice, so that's 2.09 joules per gram degree C, and then we have T sub F minus T sub I, so that's 0 minus negative 25. So this region, Q1, is going to be equal to 941 joules, which would be 0.941 kilojoules. So Q1 is equal to 0.941 kilojoules. Q2, segment 2 here, is just, there's no temperature change. So all we're doing is warming and melting the ice. We're not changing the temperature any, we're just melting the ice, okay? And that Q2, is going to be governed by the delta H of fusion. So it's the number of moles, and remember 18 grams is 1 mole for water, because water is 18 grams per mole. So number of moles times the delta H of fusion. So that's 1 mole times 6.02 kilojoules per mole. So we get 6.02 kilojoules for Q2. Segment 3 is heating the water from 0 degrees C to 100 degrees C. So whenever we have a temperature change, we're governed by the M C sub S delta T equation, because we have a delta T. So notice when we're melting the ice, we don't have a delta T. Okay, so Q3 is equal to M, which is 18 grams, times C sub S for ice, which is 4.18 joules per gram degree C, times the delta T for this process, so it's going to be 100 minus 0. So our Q3 is equal to 7.52 kilojoules. Q4 is going to be to boil all of our water into steam. Notice along Q4 the temperature is not changing. So Q is going to be governed by the number of moles times the delta H, and in this case it's the delta H of vaporization. So we have 1 mole times 40.7 kilojoules per mole, so Q4 is equal to 40.7. Okay, so we reach our final segment, which is Q5, right here, and that's just heating the steam. So again, we're changing temperature, so we're governed, Q5 is governed by M C sub S for steam times delta T. So that's 18 grams times 2.01 joules per gram degree C, And our delta T is TF minus TI, final minus initial, so it's 125 minus 100, so that gives us 0.905 kilojoules. So Q5 is equal to 0.905 kilojoules, okay? So to get the entire Q for the process, we just add up Q1 plus Q2 plus Q3 plus Q4 plus Q5, okay? And I have not done that here, so I could go ahead and do that. So let me grab my calculator. So I get 56.086 kilojoules as my Q total. So that's how much heat it takes. That's how much heat it takes to heat 1 mole of ice or 1 mole of water from negative 25 degrees C to 125 degrees C. Now I'll let you work this problem where instead of 18 grams of ice, we have 7 grams of ice from negative 15 degrees C to 115 degrees C.